All right. So we only have, I think, 3 video sessions left. If I remember correctly, we did the one last week on civilization, right? And so we'll be picking up with the one on the origin of the universe today. So if I were to just ask you in a broad general sense, what do you hear these days when you talk to people about where all of this came from? What do they tell you?
It used to be that matter always existed, but that theory has been thrown out the window. And I haven't recently talked to anyone in reference to that, but I'm sure they have some sort of reasoning.
Yeah. I remember the thing I heard, this is probably 15 or 20 years ago, and I don't even remember who exactly said it, but at first there was nothing and then it exploded. Which, when you really think through the words contained in that and the connection there, it's like, okay, that fails a logic test, at some level, right? And it's just yesterday I did see something on TV about the new telescope, the Webb telescope, the James Webb telescope. I guess they got the first infrared images back from that. They've been deploying it and tuning it and focusing it and all these other things. And of course, one of the things they believe that, that telescope is supposed to tell them is they'll be able to peer back. They'll be able to peer further into space, which is the equivalent of peering back into time. And, they hope to have answers. And the thing I was watching, which, is a pretty fair and balanced space thing that I follow primarily because SpaceX is one of our clients. And I stay on top of what's going on with space stuff, just so I know what's going on with that client, is talk about how exciting this was. And again, the idea was that the reason there's excitement is there's a desire to want to know. And so what crossed my mind, given the study that we're going through at that time, was, gee, it's nice as a believer to maybe not understand all the details, because I don't imagine for a second that I understand all the details, but just to know that I know who caused it to happen, even if I don't fully understand how it happened. And, the fact that there's such desire and incredible amounts of money, for example, were spent on that scientific instrument and all the thing that goes with that means that this is a burning question. Which the other thing that popped into my head, relating to this study and thinking about Bible study, is it only seems logical that the story of creation would be at the beginning of Genesis in the Bible, right? Where do you start? You start at the beginning. But, what popped into my head thinking about that yesterday was we're not the only ones who have this question. God, through Moses, through creating the fact that we have the book of Genesis, realized that his people had this as a question. And so he is giving them the answer. And so that was just my other reminder in my head yesterday, is this is not a new question. It's not a new area of interest. This has been going on, well, since the beginning. And so, we're at a unique time and unique place in terms of what science enables now, but it's not unique to history, if that makes any sense. So I'm going to go ahead and cue us up here for the video and get the sound sharing what it's supposed to be and all of that other fun stuff. So if you guys will tell me, you guys should be able to see the screen now. And let me know when. Optimize, there we go. Share sound and optimizing for video clip. So let me know when you guys have the audio and I'm going to get it started.
Words we all know. But what exactly happened
Y'all hear that?
in the beginning?
Yes.
Yes.
How did our universe come into being? And just how long has it been here? Science can answer a lot of questions, but can it tell us how everything began? It's our nature to want to know how the universe works, and much of our understanding begins with some essential laws of nature. The law of conservation of mass and energy says that energy can be transformed from one form to another, but it can't be created or destroyed. The law of increasing entropy says everything is in gradual decay, that energy tends to go from a useful form to a useless form. And the law of cause and effect, which says that everything with a beginning has a cause. But science deals only with the observable present. What happened in the past is not something we can test scientifically. We have to take what we know and work backward to the birth of the universe, at the instant of creation, in the beginning. Lloyd, and welcome to Unlocking the Mysteries of Genesis. Today we're going to talk about the origin of, well, everything. And we're going to get some help from Sir Isaac Newton. You remember him. He came up with some pretty clever ideas after seeing an apple fall in his orchard. In fact, his ideas were the beginning of modern physics. Newton was born in England in 1642. He was one of the greatest scientific thinkers of all time. He was a modest, unpretentious man and deeply religious. He studied at Cambridge University, where he published important works on mathematics and optics. Among his many contributions, Newton's studies of gravity and mechanics became the foundation for how we understand the universe. His laws describe how mass behaves when acted upon by a force such as gravity. The laws of physics tell us that energy cannot be created or destroyed. Take this block. When I pick it up, it now has potential energy. The energy comes from Earth's gravity wanting to pull it back. If I drop it, the block is in motion. The potential energy becomes what we call kinetic energy, the energy of motion. It's the first law of thermodynamics. Energy cannot be created or destroyed, just converted to another form. When it hits the counter, the energy changes again to sound and heat this time. But it's still energy. It's the same amount that the block had when it was falling. It's just taken on a different form. You can see it here too. As the energy is transferred, some of it becomes sound and heat. So even though the amount of energy in the universe is constant, the quality is constantly running down, much the way these metal balls slowly lose momentum. This is the law of increasing entropy. Same with the wood block. All that energy it got from gravity still exists, but it exists in a different form. The energy transforms into sound and heat, and it doesn't do the block much good. The energy available for useful work has decreased, just as it is decreasing for the whole universe. Which leads us to the third principle, the law of cause and effect. This block isn't going to move again unless I move it. Cause, effect. So you're thinking, well, that's good, but what does that have to do with the origin of the universe? Well, come with me. We're about to find out. Our concept of the universe has expanded dramatically in the modern age, thanks in part to powerful telescopes like this one. Our understanding advances with technology as more and more tools are becoming available to astronomers and physicists, people like Georges Lemaitre, a mathematician and Catholic priest from Belgium. In 1927, he published a scientific paper that didn't get a lot of attention at the time. In it, he explained the relation between the distances and the speed of movements of galaxies. He made a case for an expanding universe and showed how space itself could be expanding, carrying galaxies further outward. Now, about this time, an American scientist, Edwin Hubble, was using the Mount Wilson Observatory to measure the distances between galaxies. Hubble's observations revealed evidence that Lemaitre and others were correct. The galaxies seemed to be moving further away from each other. Lemaitre suggested that if the universe was expanding, then it must have been smaller at its formation. He proposed that everything began at one moment in time. Lemaitre proposed that the universe started out smaller than an atom. Then he took the idea of an expanding universe and worked backwards in time to a point when everything would have been squeezed into a single particle, what he called the primeval atom. When this particle exploded, he theorized that it created everything, all space and time, in what secular scientists now call the Big Bang.
The Big Bang is the most common secular idea for how the universe began and how it came to be the way that it is today. Basically, the view is that the universe started as a point, a singularity. All the mass, all the galaxies, everything that would become galaxies was in that point. Even space itself is allegedly contained in that point. And then that point rapidly expands, carrying out energy with it. Now, some of that energy turns into matter, basically. It becomes hydrogen and helium gas, which then turns into stars and galaxies and so on. And this basically is the secular idea of how the universe came to be.
But what evidence do the secular scientists offer to support their ideas? The universe, as we know it, has over 100 billion galaxies, each with billions of stars. According to the Big Bang theory, as the universe expanded after the primeval explosion, its energy cooled and became microwave radiation. In the 1960s, scientists detected microwave radiation coming from all directions in space, a cosmic microwave background, or CMB. Could this be the afterglow of the Big Bang? Many physicists accepted the CMB as compelling evidence for the Big Bang theory. NASA has launched satellites to study this microwave background radiation. The most recent was the Planck satellite, launched in 2009. The Big Bang assumes that there would have been hot spots and cold spots in the early universe. These should still be visible today as substantial variations in the temperature of the CMB. It's ironic that Big Bang scientists consider this microwave radiation to be one of the strongest arguments for the model. They think of it as a successful prediction. But the CMB is much more uniform than Big Bang supporters had originally predicted, and has only subtle variations in temperature. Planck also revealed some other surprises. Although the tiny fluctuations in the CMB are supposed to be similar in every direction, they are not evenly distributed. The data seem to suggest a special direction in space, contrary to the predictions of the Big Bang. What this means is that improved measurements of this radiation may actually be challenging the Big Bang rather than confirming it. Let's see what scientists have to say about this.
What we found is that the cosmic microwave background is very uniform, with very small hot spots and cold spots, 100 times smaller than what the Big Bang supporters were expecting. So really, it's not the right kind of cosmic microwave background to support the secular model. Now, the way that Big Bang supporters have tried to deal with the very uniform nature of the cosmic microwave background, which was not predicted in the Big Bang, is they've invoked what they call inflation, or cosmic inflation. And it's the idea that the universe basically, when it started expanding. It then suddenly expanded at a much faster rate, the inflation phase, and then it dropped off to that slower rate afterwards. And this could alleviate what we call the horizon problem, the fact that you find these very smooth temperatures throughout the universe. What's interesting is that secularists tend to hold to a uniformitarianism philosophy, the idea that rates and conditions are basically constant. Inflation really is a violation of that principle, because it says the universe suddenly expands at an accelerated rate and then drops down to its regular rate and so on. And that really is a violation of that very uniformitarian principle. So it's interesting that secularists have had to violate their principle in order to save their principle, which is inherently contradictory.
Well, when we look up at the sky, our instruments can detect this radiation, this very uniform electromagnetic radiation that's coming to us from all directions in space. And the peak intensity of this radiation is in the microwave part of the electromagnetic spectrum. That's why they call it microwave background radiation. Now, the secular cosmologists interpret this as this relic leftover radiation from a time about 400,000 years after the Big Bang. And in fairness to them, that they did predict that there would be this afterglow, if you will, from the Big Bang. And so they consider this to be one of their strongest arguments for the Big Bang. But what's interesting is we get better data, better measurements of this background radiation. It's actually starting to cause them some headaches. One of the reasons for this is that one of the fundamental assumptions of the Big Bang is something called isotropy. And that means that any direction in the sky should be the same as any other direction. In other words, if I look at the background radiation over here or over here, we really shouldn't see any large-scale differences. Well, it turns out we do see some subtle differences in different directions when we look at that radiation.
So, was the universe formed by a Big Bang, or is it God's creation? If it all began by random chance, in a giant explosion, it seems we would expect to find pure chaos around us. Think of the most powerful natural phenomenon we can observe today. Events like tornadoes and hurricanes. They leave behind destruction and disorder. But our universe shows exquisite order and precision. We don't have to look any further than the sun. Gravity keeps the sun's hydrogen together, creating the intense pressure that leads to nuclear fusion in the solar core. There, hydrogen nuclei fuse into helium and release energy, the energy that keeps our planet alive. With all that explosive energy, you'd think the sun would destroy itself, but it doesn't. The laws of physics holds it together. The high temperature of the sun creates pressure that pushes outward on its layers of gas. But the force of gravity pulls inward on these layers. These two forces are exactly balanced, resulting in a stable sun. This, and not random chance, is what keeps billions of stars burning in billions of galaxies. The laws of physics describe the way that atoms and molecules are held together. If these laws were changed even slightly, atoms and molecules would not exist, and life would be impossible. This beautiful order and precision points to a plan, a moment of divine creation. There's evidence for it all through the cosmos.
A galaxy is a collection of millions to perhaps trillions of stars. And there are several different types of galaxies. We have these big elliptical galaxies, we have dwarf ellipticals, but one of the most common types is a spiral galaxy. These tend to have a disc shaped with a bulge in the center, and the disc tends to have spiral arms. The stars are organized into these beautiful spiral arms that you see in some of these grand design galaxies. Now, the interesting thing about spiral galaxies is that they rotate differentially, which means the inner portions rotate quicker than the outer portions. So the inner portions are doing this, the outer portions are doing that, which means that spiral structure is constantly twisting tighter and tighter. It's called the spiral winding problem, but it's only a problem in the secular view, because if the galaxies really were billions of years old, they would be twisted beyond recognition. But they aren't. We find spiral galaxies all throughout the universe, and so that's a suggestion that they're not anywhere near their alleged secular age of 10 billion years or so. They must be much younger than that. Blue stars are also an indication of the youth of the universe. You see, blue stars are some of the most massive, most luminous stars that exist. They expend their fuel at an incredibly rapid rate. Even though they have a lot of fuel available, they're very massive, they burn it up very quickly. It's kind of like an SUV. They've got a big gas tank, but they get very poor gas mileage. And for that reason, they cannot last hundreds of millions of years. In fact, the hottest, bluest stars, even secular astronomers will acknowledge, they can't last even a million years, some of these. And yet we find them all throughout the universe, a universe that's allegedly 13.8 billion years old. Some people have asked, well, why can't we just say that God created over billions of years and whatnot? Why does this really matter that the universe is young?
And when you look at the Big Bang model, it's part of this overall evolutionary story where you have death and suffering going on for hundreds of millions of years on this planet, supposedly before man was even appeared on the face of the earth. So, how do you reconcile that with God's love for his creation?
There are a lot of different lines of scientific evidence that confirm that the Bible really is what it claims to be. It really is the Word of God. We've seen that when the Bible talks about life, animals reproducing according to their kind, well, that's exactly what we observe in the world. When the Bible touches on astronomy and it talks about the circular nature of the earth or what have you, we find that's exactly what we observe in the world. The Bible's right in all these issues. You see, the reason that science works is because God upholds the universe in a consistent and uniform way, and he does that for our benefit so that we can understand it and write down equations that describe how God upholds the universe. Equations like E equals mc squared, for example. Now, how would that be if the universe were just a chance accident? Why would it be that it obeys these nice, neat little equations that we can write down? Why would the human mind be able to understand those equations? And so you see, my question is, how would science even be possible apart from the Christian worldview with creation at its foundation? It's interesting that my secular colleagues try to use science to discredit Scripture sometimes and say, well, we think the science leads us toward an evolutionary notion. But it seems to me that if evolution were true, there'd be no reason to trust the methods of science in the first place. The Bible alone makes knowledge possible, and I haven't seen any secular worldview that can do that.
Creation and secular scientists agree about the laws of physics and mathematics. These basic principles, the ones Isaac Newton helped formulate 300 years ago, still accurately describe the stability in natural processes. And the Bible reinforces this. It teaches that God upholds the universe in a consistent and orderly way for our benefit. In Genesis 8:22, we read, "While the earth remains, seed time and harvest, cold and heat, winter and summer, and day and night shall not cease." God is promising here that the basic cycles of nature will continue as long as the earth remains. This includes the law of conservation of mass and energy. Energy can be transformed from one form to another, but it isn't created or destroyed. As the Bible says in Isaiah 40:26, "Lift up your eyes on high and see who has created these things, who brings out their host by number. He calls them all by name, by the greatness of his might and the strength of his power. Not one is missing." Since God finished his work of creation by the seventh day and continues to uphold what he's made, energy cannot be created or destroyed. Secular scientists have never adequately explained the first source of energy that created the universe, or supposedly caused the Big Bang. Some claim that inflation is the dynamite that caused the Big Bang, but they don't know what lit the dynamite that caused the explosion. Many of them now acknowledge problems with the Big Bang theory. They have either proposed alternate models, which themselves have serious problems, or they have suggested major revisions to the current model. While the Big Bang cosmologists keep looking for explanations, let's see how the scientific evidence confirms what the Bible teaches about creation. How does the Bible show us that God created the universe? We'll begin in the beginning, in Genesis 1:1. "In the beginning, God created the heavens and the earth." The first book of the Bible describes the time from the initial creation of the universe to the creation of man. On day one, God created space and time, matter and energy. God, the engineer, was making the raw material ready for organization. He inserted light into the darkness of space, turning the earth and separating the light, day, from the darkness, night. In Psalm 74:16 we read, "The day is yours, the night also is yours. You have prepared the light and the sun." And as the Bible says in James 1:17, "Every good gift and every perfect gift is from above, and comes down from the Father of lights, with whom there is no variation or shadow of turning." God is consistent and upholds all that he's created. The original energy that he put into the universe is still here. The first law of thermodynamics says that it can't be created or destroyed. But what does the age and origin of the universe mean to us in our everyday lives? It means the difference between chaos and order, chance and design. Everything around us exists as God has decreed. And the law of entropy shows us that the universe can't be eternally old, because all that energy would have been degraded into a less useful form by now. And if the universe is not eternal, it had to have a beginning. And as we know from simple logic, every beginning requires a cause. The law of cause and effect. But how could it have begun? Some might claim that the universe made itself, but is this logical? How does the universe, how does anything make itself? I can think of only one remaining alternative. The universe must have a creator. What do you think? I'm Marcus Lloyd. Thanks for joining me. I hope you'll come back for our next episode when we'll take a closer look at our own solar system. We'll explore Earth's place in it and ask, are we special? Are we alone in the universe? Or is the Earth just one of many planets that could support life? These are some of the questions we'll explore next time on Unlocking the Mysteries of Genesis.
Can't hear you. Yeah, I can hear you.
My bad.
Okay.
I had muted because I was coughing still a little bit. Am I the only one that gets lost in the science sometimes?
No. It's over my head. Mine too. But what's not over my head is to ever think that all the detailed intricacies of everything could have just come from anything other than a designer creator.
And again, this occurred. He talked about, you change the. This is at the nuclear level, inside the atom. If you make small changes to any of the way that these things work, everything just sort of falls apart.
Yeah.
And we're not talking about wide ranges of what I'm looking for, tolerance. The tolerances are incredibly tight. And again, that also suggests design, right?
But I will say I'm very impressed and as knowledgeable about just what goes into study of these things.
I agree. And yeah, I think the thing that, we typically see either portrayed on TV and documentaries or, however things manifest themselves, we tend to see the secular worldview, expounded scientifically, but there are a lot, and I'm talking about a lot of scientists that have a Christian worldview that are not checking their intellect at the door, that are engaged in this exploration and this understanding.
Yeah.
And I think it's easy to, unless you're intentionally seeking those voices out or going to the places online where those voices are heard and are gather and that type of thing, it's easy to just assume that, 99.9% of all scientists believe in a secular view of this, and it's an extreme minority that looks at things from a biblical perspective, and that is simply not true.
I think after Carl Sagan, we began to realize there was an enormous amount of scientists that really disagree with a lot of his theories.
Yeah, and the fact that, you know, it's easy for things that are theories that have been unchallenged, because, well, a good example was they were talking about the Planck satellite that was, you know, they sent it up looking for these hot spots in the cosmic background radiation. In other words, the theory had a prediction about what they expected to find. And guess what? They did not find it. I don't remember that being splashed across the headline of the evening news. I'm pretty sure if there was something that had reinforced that theory, it would have been, you know, much more prominently displayed.
Have we heard any more about Mars having life on it? It seemed like that NASA came out some time ago, several years ago, I don't know how many years ago, indicating that they believe that there's life on Mars. And I don't think that's the case at all.
Yeah, that was actually, I don't know exactly what it was, but I remember, and by the way, that the initial announcement on that was the belief that there was meteorite fragment that was detected in Antarctica that was Martian in its origin, that had evidence of life. That, I don't know exactly what year it was, but I can tell you the period of time that it must have been in because it was during the Clinton administration.
Right.
Okay, so what they're
that was
saying
sometime
now,
between 93 and 2001.
so what they're saying now is that there is, they've actually found water on Mars, and they're looking for microbial life. They're not looking for like humanoid life. They're looking for any type of evidence of life. So it's not like they're looking for aliens or other creatures. They're just saying that we believe that there's water. They found some stuff up in some of the frozen parts of Mars, and they're in the process of developing things so that they can get samples. One of the rovers is doing that. And then so when they're looking for microbial life. They're not looking for the same kind of life that you might be thinking of.
Right. And that's a valid, that's an important point, Lori. Thanks for sharing that, in the sense that when we're talking about, you know, is there life elsewhere? Modern science would be jumping up and down happy if they just found a microbe. Not the organized complexity of life that we represent or that's represented on this planet. You know, any life would be life, right? Not a civilization level, you know, life. Any other thoughts or comments on what we just watched? All right. We only have 2 left, so we probably have 2 weeks left. And I don't think we'll manage to squeeze into, is this still been a valuable study? Was this a good choice?
Yes.
Yes, I have really enjoyed it.
Good. They're real easy for me to prepare for. I just got to watch a video, be ready to lead a discussion and cue it up. So it's been a nice little break for me from the 2.5 years before. So that's been good for me too. All right. Anybody have anything else? I'm about to stop the recording.